but it does look as though both the medium wave and the long wave bands are both working, although there doesn't seem to be very much on medium wave at the moment, but maybe that's not surprising. Let's have a go. I think this one, I think that one's medium wave. Let's have a go. Normally my medium wave reception isn't particularly good here, and again, unfortunately, because this has got a self-contained aerial, it's not like I can plug in my long wire, my external aerial, which I usually run my valve sets on. So I suspect it could just be a little bit low on signal, so let's go ahead and plug a signal generator in. Well, this radio's been powered up for about 20 minutes and everything's starting to really get a bit toasty now, and I've got that absolutely beautiful smell of the dust burning off the valves, and particularly it's going to be burning off this mains dropper resistor here, and the whole workshop is just being filmed with that warm nostalgic smell of valve radio. Very special. So I've got my loop antenna set up on the bench. Let's see if we can actually tune in to well, mid-band. So we've got a signal set up of around 856 kilohertz, so I think that should be around 350 meters, which in theory should be about centre of our medium wave dial, I think. I'm not actually sure which is medium wave on this. Well, I'm guessing that must be long wave. Okay, so there's our signal being picked up on medium wave now. And I'm actually putting quite a high powered signal into my loop antenna here. Which kind of makes me think that perhaps this radio is a little bit deaf and some alignment will be required. We will go ahead and do an alignment on it anyway because, well, we should do. Well, I think our Bush DAC10 woke up quite successfully now, and it looks as though this radio is fit for restoration. So what we'll do is, I think we'll go ahead and I'll start changing out all these waxy capacitors. I'm not going to make you watch that, so I'll bring you back when we've finished. Well, as you can see, we've gone ahead and we've swapped out most of those horrible waxy capacitors, and I think what we'll do is we might test a few of those later to see how bad or good they in fact were. But I think you could probably say we've actually left the best till last, which is this really horrible, disgusting across the mains capacitor. We found that somebody's actually snipped this out previously and they've actually replaced it with another polypropylene cap down here. But the one that's been put in there is looking equally dubious, and yeah, it's certainly not a rated capacitor to go across the mains. So we're going to swap that out while we're in here. And I've also just noticed another capacitor which is tucked right down here that you can't see, which I think maybe is for the tone, and yeah, I'd obviously missed that, so we're going to go ahead and get that out, I think. Well, it was creeping me out a bit, you guys standing right behind me, so I've moved you back a bit just to give me a little more room. Wow, this capacitor is just so horrible and melted. I'm going to have to go and wash my hands when I finish playing with this because it's just a puddle of sticky goo. There we go. Yeah, and at some point this is, well, I can see it looks like almost as though it's been on fire. It's actually blown out from one end. Do you want to take a look? Yeah, okay, I'll bring you in. Yeah, so somebody did the right thing and in the past they cut this out. I can see the actual plate material inside it, it's just all burnt. Shall we get gooey? Shall we go in deep and have a look at the material? It's stuck to the board. Oh dear. So this is all that a paper capacitor is. It is just waxy paper with foil on one side and kind of a set of foil on the other side of it. So hopefully we should find something a bit burnt in here if we unravel it. Okay, a bit of a mark there, but it looks as though the main damage is deeper into it. Okay, there we go. So you can see here that the actual foil is actually, it's double-sided, but one side of the foil is just burnt away. So we probably can't unwrap this any further because it's just too burnt. So I think maybe the middle section was okay. Looks as though the burn all occurred in just one spot. And of course it only does take one spot for the capacitor to go bad. Okay, yeah, so the rest of that seems fine. And just looking at the rating on this, it was a 500 volt DC type 543, British made by the TCC company, 0.1 microfarad. What a mess. Gonna go and wash my hands. Probably find my fingers will fall off after touching this stuff. Can't be very good for you. So these are all the old capacitors that we've taken out, and I think most of them are either 500 volt rated or 1000 volt rated. And actually, having taken a look at quite a few of them, I can actually see that a lot of them have actually got serious kind of burn marks where the leads exit the body of these. So it's obvious that a lot of these capacitors were obviously quite bad. So that one has a great big burn mark at each end. I think that one also has a burn mark on the end cap. And this one, which was one of the grid coupling capacitors, it's actually bulging at both ends, and one end the wax is cracked away and it's totally black. So I think again this had some voltage across it and has been damaged. So it looks like most of these capacitors are in a pretty poor way, but let's go ahead and just test a few of them. So I think that's a 500 volt one. Let's see what that measures. And that capacitor's measuring a dead short, so that was no good. This capacitor here was across the mains. This is one that would have been X-rated. Now it has got 1000 volts DC rated. It's 0.1 microfarad. Again, let's try this one at 1000 volts then. I suspect this one might be okay. Okay. Yeah, that's measuring 700 meg and climbing, so that one does look okay in fact. I'll put that on the bench there because I'm sure I'll forget its charge. Let me short it out just to be careful. Ooh, bang. 350 volt working. Let's try that on 200. That's measuring dead short as well at just over 200 volts. Okay, got another 350 volt rated one. Let's try this one at 250 volts. And that's measuring a short circuit as well. So actually it's amazing that this radio was working at all, because most of these capacitors are actually failing their voltage rating. Now of course it depends what position they are in the circuit. Just because it's a valve radio, not all the positions in a circuit where these capacitors would be installed would have high voltage across them. Some could just have a few volts across them, in which case it would have probably been fine, but I think you can see that generally this is why we change waxy capacitors out. They're not good. Now if any of you can tell me why I actually keep old capacitors, well, leave it in the comments, because I've got absolutely no idea. What do you think? Should we give it another try? I think we should. Now unfortunately we're never going to do amazingly well in my room for either long wave or medium wave reception actually. So what I'm going to do is I'm going to use this loop antenna. And I did actually make a video on this, so if any of you want to know how to make these loop antennas, they're very, very simple, but they're a good way of actually doing radio alignments, and you can also use them just to transmit. If you've got a signal generator, you can use them to actually transmit some audio into the radio so you've got something to listen to. I'm actually fairly sure this main smoothing capacitor is actually fine. It will be changed out because we can't trust it after 60 years. It is an electrolytic, and even though it measures fine and checks fine, the reality is it cannot be fine after 60 years. The electrolyte has dried out and it needs to be changed. So what I was doing there, I was just adding some more capacitance to this main smoothing capacitor to each of the two stages. There's a 15 microfarad side and I think it's a 32 microfarad side, so basically just going between them. If this capacitor was likely to be failing, usually strapping another capacitor across them will actually tell you that, it'll show you that. Don't seem to have a problem with that, so again it makes me think that probably our rectifier here is just on its way out, and that's why we're getting a low HT voltage. Now unfortunately I don't think I have another rectifier valve, but that doesn't matter too much because this radio will work as it is. We will have to change it out at some point in the future though. Well, the other thing that might be causing our low voltage on this radio, I was thinking it could be these bulbs, couldn't it? Because well, they were very, very dim, weren't they? And so not all the light was coming out of the bulbs because they were dirty. And it's a little bit like the exhaust on your car. I don't know if you've ever had a car and the catalytic converter's blocked up and your engine performance really suffers. So I think what we need to do is we need to take both these bulbs out and give them a little bit of clean, because it could be the electrical back pressure which is just making the voltage drop a bit. Now I actually thought all the wiring on this radio was actually pretty good, but having a look at this now more closely, I can see that the wiring going up to these dial lamps has actually crumbled away, so I think we will have to address that. Now luckily this wiring shouldn't be too difficult to change, he said, although saying that I'm not exactly sure where it goes to. Let's hope it goes to somewhere it's not too inaccessible. Okay, so it does appear to go to the back of the main switch. Yeah, so it's probably important that we change that, because I'm guessing this has got potentially mains voltage on it, so yeah, maybe it is as well we spot it and change that out. Oh, this is one of those difficult tag strips that's got things tied on top of things, which is also tied on top of things. Okay, we now have no things on top of things on top of other things, so that's an improvement. Okay, well I've just gone ahead and I've given these light bulbs a really good polish, so hopefully the HT voltage will have come up a little bit now. Let's give it a try. The bulb cleaning didn't work. Maybe I'm all out of options now. Let's go ahead and try as a last resort to swap out this rectifier valve. Well, I'm afraid I've actually just taken you on a bit of a wild goose chase. Now, as it turns out, the actual HT voltage for this radio, it's actually about right at should be 190 on the anode of the output valve, and I think I was measuring 185, so that is actually pretty much spot on. It's close enough. My mistake was I was actually just reading the wrong part of the service sheet. I was reading the incoming voltage, the AC voltage to the rectifier, and not the output, so that was my mistake. Now, just to finish off with today, I think we'll go ahead and I'm just going to change out this main smoothing capacitor. Now, it does measure good. We haven't really found anything wrong with it, and it isn't getting hot in service or anything like that. There's a lot of different opinion about changing capacitors out and components out when you don't need to, but I'll simply say that my thoughts are that after 60 years service, the electrolyte in this capacitor will have dried out, and although it may not be causing a problem right now today, that doesn't mean that it won't cause a problem in the future, and I would rather not have to deal with it then. So what we're going to do is we're going to change this out, and because I don't want to spoil the look of the radio, I think we're going to go ahead and I'm going to try and restuff it with some new capacitors. So that's the plan. Oh, bugger. Thought I was going to get that open with that then. Plan B, I'm going to go in the garage and I'm just going to cut this can open. Now, I said earlier that it was vitally important to actually take these out of service because they will be all dried up inside. Well, I have to report that again, I was wrong because, well, this one was as wet and moist inside as a coating man could want. But they're not always that way. I mean, I've actually restuffed a lot of capacitors in my time, and usually they are just very dried up inside, but this one wasn't. As I actually cut into it, the actual dielectric fluid actually poured out. Well, whoever made these capacitors back in the day, they certainly did a good job. Even if you got another of these radios that was exactly the same, that wouldn't guarantee the capacitors being any good. I don't think you can take the chance. I do think you have to change them out. So these are the capacitors that we're going to use. What we're going to do is we're going to take some new wires through the can of here. Sometimes you can actually drill through the centres of the rivets and you can push the actual wires through them. Sometimes that works, sometimes it doesn't. So what I'm going to do is I'm just going to drill some little holes adjacent to the existing connectors on the capacitor. I'm going to push the wires through and then solder them. So I think we'll start off by just giving the old capacitor terminals a bit of a clean because they're all a bit of a mess. Okay, them terminals look pretty good now. Let's start off by putting our ground terminal in. Sure, a lot of you saying, why do I keep using flux? Well, when working on old components, I wouldn't say you absolutely need flux, but if you have a little bit of flux on, you can make the solder joint quicker. You don't have to wait quite so long for the flux which is in the solder to activate, and I think that's a good thing because you kind of do a lot less damage because you can get in and out more quickly. Now I'm putting a little red tracer on here, which, if nothing else, it's just a little memory aid to me to get these capacitors the right way around, because if you get these the wrong way around, it's going to go with a very loud bang. So the two capacitors that I'm putting in here, one of them is I think is 33 microfarad, and the other capacitor that I'm putting in is 22. Now it should be a 15. I don't have any 15s, but the reality is we don't exactly need to fit a 15. Now you do have to be careful when you're installing capacitors into valve radio circuits that you don't put too big a capacitance value in, and the reason you have to be a little bit careful is that it is possible to actually overload the rectifier. You can draw too high a pulse current, which can be damaging to the rectifier. So what you actually need to do is not put too big a capacitance in there, you know, replace the capacitor with the same value that came out. That's probably the best idea, but I'm not doing that in this case. But the capacitor that I've actually gone slightly bigger with, it's on one side of the smoothing resistor, so the actual rectifier doesn't really see it as such, so it's okay to go a little bit larger. So the negative side of the two electrolytic capacitors, they just join together inside the can, so that's nothing technical. Okay, so that's our capacitor restuff. Now you don't usually need to do any more than that. Sometimes what I do is I go ahead and I just put some hot melt glue just to stop them shaking around, but the wiring is quite stiff, so it's not going to go anywhere. Okay, so there's the 22 microfarad section. It's actually coming up as 21. Let's try the 32. 32 is coming up bang on 32, so there's our capacitor. Okay, so our first HT voltage is 191. The datasheet for this radio says it should be 190, so we've gained 5 volts. And what's the other one at? The other one is at 77 volts. I'll have to check that. Well, as you can no doubt see, I've gone ahead and I've removed both the speaker and the output transformer from the case of the receiver. Reason being that I wanted to give the case a really good clean and wash it out before I polish it, because it is full of dust, and some of that dust could be asbestos, because there is some asbestos insulators that sit under the main dropper resistor there. But it does give us the opportunity here to look at this speaker that I mentioned earlier. So let me just turn it over. And what I was commenting on was the fact that you can see that there's no magnet, no obvious magnet on the back of the speaker here. Now, unfortunately, I don't think I'll be able to get the camera in at an angle where you'll actually be able to see this magnet, because it's actually obscured by this metal plate which actually supports the magnet itself. Now, doing a little bit of research into the DAC10 radio, it turns out that the reason that they did mount it in this way was just to save a little bit of space. Yeah, I mean, it makes you wonder how much space they did actually gain, but they obviously thought it was worthwhile. Now, I can actually see we've got quite a lot of dust in here, so that is going to give me the opportunity to, again, I guess, take this outside and hoover the dust out of it. Maybe we can clean it up a little bit better before it goes back together. However, now we've actually removed the speaker, it's actually given us the opportunity to inspect some of the wiring between the speaker and the output transformer a little bit more closely, and as you can see, it was probably okay before I touched it, but it's gone solid. So actually, if I just flex this wire now, you can see the insulation's just crumbling off it. So it might have been okay at first inspection, but it's actually clearly not. So while the radio's out, let's just take the opportunity to replace this wiring as well. Well, having removed our transformer, I've also just spotted that we've got one of these Zobel capacitors, which is actually installed across the primary of our output transformer, and the function of that is just to help roll off some of the high frequencies, and I think to stop the output valve can go into oscillation without it, so that's what that's for. So it is an evil waxy capacitor, so of course we do need to change it out, but it's actually interesting that you should generally always change these out on a valve radio, and the reason you need to change them out is because these are actually quite highly stressed for quite an interesting reason, because actually a transformer, it's just a big coil of wire, and if you get a big coil of wire, that's an inductor, isn't it? So much like things like electric motors, when you pulse the current through them, you can get quite high back EMF voltages that appear across the terminals of the inductor. So these capacitors they actually do see a much higher voltage than, for example, the actual voltage on the output of the pentode. So if I was replacing one of these, I'd probably replace it with a minimum of a 500 volt capacitor, and if I had one to hand I would probably put 1000 in. What I'm going to replace it with is a 600 volt capacitor. Let me just have a look. Yeah, 630 volt capacitor, because, well, that's about the best thing I've got in stock. That will be perfectly adequate. And of course, as we expect, it is in fact wire wrap city, so let's just get rid of that. Actually, it didn't put up too much of a fight in the scheme of things, did it? Okay, I think I'm going to call that good enough. Well, I seem to remember that when I last checked it, our HT voltage was a little bit lower than I liked. Well, this radio actually employs what they call capacitor resistive smoothing, and I think I mentioned that in part 1 of the video. So what we've got here, we've got a 10k resistor and a capacitor in front of it and a capacitor behind it. So on one side of the resistor, effectively, I think I was getting about 190 volts. and on the other side of the resistor I was only getting, I think it was something like 79 volts, and I was looking for something in the region of, I think it was 98 or something like that. So what I suspect has happened is there's a very old-fashioned style of resistor here, which I will call a dog bone resistor. Unfortunately I can't really get you in, you can just see the end of it there. I suspect that the reason that on one side of the resistor our voltages are a little bit low is because this dog bone resistor has probably gone high in value. It should be a 10k. Let's see what it is now. And it has indeed, it's actually 12k, and it should be nearer to 10. I think if we actually change that out with a 10k resistor, that would probably solve our issue of having a slightly low HT voltage. Now unfortunately I don't have a suitable 10k power resistor to hand, so it's going to have to remain as it is, at least for now anyway, and maybe at some point in the future I will go ahead and change that out. Never.